Hey, good morning, you guys. I just wanted to give you another recap of what we've talked about so far in this unit that's been the most vital. So we have been calculating confidence intervals of proportions using p hat to estimate the true p. So a couple reminders. Here's the three Z critical values. If you're planning on trying AP stats or taking stats in college, things like that, moving forward with statistics, make sure you know where these numbers come from. Otherwise, you can just have these three written down because these are the three that are used most frequently. Another note, don't forget that the conditions are checked to see if it's random, and then is NP greater than equal to 10, and N times 1 minus P greater than equal to 10. All right, so here's a warm-up for you to do just to kind of get some practice. Go ahead and pause the video, and then when you're ready, we'll start talking about our answers. All right, so first thing we need to do, okay, there's a lot of steps here. So what I'm basically going to do is kind of reveal everything for you guys and just highlight as we're going. It's a lot easier on this time frame. So first things first, we have to find our point estimate. And it said 45 out of 200 students said they've been absent more than 10 days. So when we're trying to find that percentage, we just divide those to get our point estimate. Notice that in my final answer, there's my point estimate right there. The other thing we need to do is figure out the margin of error. So first thing we have to do is find the standard deviation using that formula from our previous lessons. So you'll notice how that number goes into my equation over here. But we need our Z confidence interval. Remember, there's two different ways you can get that. You can either have it memorized, written off to the side, that's totally fine. Or if you also think about it, if we're 95% confident, there's 2.5% on either side. So you can use inverse norm with 2.5%, which has a decimal is 0.025, to also get that critical value as well. And that's where this final answer of the confidence interval, this guy right here, came from. Now, having said that, that's not your final answer. Like, yes, that's your numerical final answer, but we want to make sure we're answering in complete sentences. So this part right here is the true final answer when you're finding confidence intervals, okay? We are 95% confident that the true proportion of students absent more than 10 days lies between 16.7% and 28.3%. Where I got these numbers from, you guys, is I just did 0.225 plus 0.058 and made it a percentage. And then I did 0.225 minus 0.058 and made it a percentage, mainly because it did say what's the interval for percentage. So I thought switching it up might be a better way to word it. You could also say that the true proportion lies between, and you could have just literally used this exact value, and that is the exact equivalent of a correct answer as well, okay? All right, so now we're going to talk about, there's a 4-step process when it comes to confidence intervals, and we're going to use this 4-step process for the rest of the school year, so all the way through to the end of the school year. Basically what it is, it's kind of like in science when you guys do your lab write-ups, for example, it's kind of the same idea. So the 4-step process, it's the same for the rest of the school year, so you only have to memorize it once, which is great, is state. Okay, so state, what exactly are you going to do? Like, what are you trying to figure out? Okay. Plan. So what's the appropriate method? And then that's where you also check your conditions. Like, can I actually find this confidence interval? Do I have enough data? Is my sample size big enough? That sort of thing. Do is basically all this stuff over here. You'll notice I kind of put do right here. Okay. All this stuff right here is the do. It's the calculations. It's the quote mathy part, I guess. And then conclude is your literal final answer. So this guy right here, the sentence that we wrote right here, that's like your conclude. Okay, so pretty much we've been doing everything already. We just need to kind of formalize it a little bit and make it look a little bit more professional. So here's a problem to give you guys a try. If you want to give it a try with this idea, go for it. This is an example though, so if you'd like to just listen, you can. So basically we're talking about 1,029 US adults. 78% reported that they often or always get enough sleep the last 7 nights. Calculate and interpret a 95% confidence interval for the proportion of all Americans who would say they often or always got enough sleep the last 7 nights. So we're using this sample proportion to estimate all Americans. So here's how this goes down. I'm using a shade instead of writing it all out because otherwise this would take me a long time to do on a tablet. So hopefully you'll forgive me there. So the state looks something like this. We want to estimate the true proportion of all Americans who often or always got enough sleep with 95% confidence. Literally, you guys, the state is pretty much rewording the question. And if they don't tell you what confidence interval percentage you're using, like if they don't tell you 95%, that's where you would say, this is the percentage I'm using. Okay, so that's the purpose of the state, is kind of reword, this is what I'm trying to find. For plan, that's when we check all of our conditions. Okay, so first thing we need to figure out is it random? Well, it did say a random sample of 1,029 students, so we're good there. And then you'll notice my calculations for NP and N times 1 minus P. Both those calculations are greater than or equal to 10, so we're good. So the next thing you would say is, all right, we can move forward with what's called a Z interval, okay? That's just something you have to have memorized, okay? That this is called a Z interval. Think of it as it's a proportion confidence interval, and we use Z to help find our calculations. So think of it that way. Here's my do, which I'm not going to go over too much, right? The point estimate was that 48%. Off to the side, I found the standard deviation, or the estimated standard deviation, by using that formula, the N, or the P times 1 minus P over N, and then you take the square root. Okay, so that number went right here. And because it was a 95% confidence interval, I just knew to use 1.96. You don't have to recalculate that every single time. If you have it memorized, saves you a lot of time. So therefore, here's my conclude. We are 95% confident that the true proportion of Americans who often or always got enough sleep lies in the interval 0.48 plus or minus 0.031. I chose to write it with the point estimate plus or minus margin of error to show you can write it like that, or you can write it like we did with our warm-up where we actually find the lowest number and the highest number. Does not matter, okay? So you can do it either way. If you do it differently than what I do on my answer key when you go to practice this, don't panic. You would still get the correct answer, okay? All right, so this slide has a lot of stuff on it. If you would like to read through it, you can. Basically, the idea is what if we want only a certain amount of margin of error? So what if my company says, hey, you can estimate this, but I need to know within 5% either direction. So maybe they give you the margin of error, and that kind of defines, you know, okay, how big or small of a sample size do I need? Okay, so that's kind of where I'm going with next. So here's an example. Suppose you want to estimate P equals the true proportion of all students at your school who have a tattoo with 90% confidence and a margin of error of no more than 0.07. Basically, that's saying plus or minus 7%. That's your margin of error that you're okay with. Now, I know this is kind of a weird one, like why would you have boundaries on what you're trying to find? But usually when data analysis people or statisticians are trying to find values, they have a boss or a company or restrictions that tell them this is how much wiggle room you have, right? Depending on the severity of the situation. So here's what you would do. You would start with that formula where that margin of error, usually it's the point estimate plus or minus the margin of error, right? So we're saying, all right, well, the margin of error is 0.07. So I'm going to start here. And the margin of error comes from whatever that Z critical value is multiplied by the standard deviation. So, and technically we're using p hat, so I should probably change that there. And so essentially we're saying, okay, I don't want my number to be any bigger than 0.07. So how many students do I need to survey? So what's my N? What's the sample size I need to stay within that 0.07 limit? Okay. So the next thing I do is, since it's 90% confidence, I plug in my Z critical value. Notice how I'm using 0.5 for p hat. Up here, there is no p hat. They didn't give us one because I haven't sampled anybody yet, right? I'm trying to figure out how many students I should sample before I move forward. So when that happens, we tend to use 0.5 and 0.5. The reason for that is if you don't have something to work with, you kind of want to use the largest number possible. So like I could do maybe p hat is 0.2 and then the opposite's 0.8. I could do 0.4, 0.6, and so on. But notice how the numbers are a little smaller. Okay, that's kind of why we typically use this. That's just a rule. If they don't give you p hat, use 0.5, okay? So then I start doing my calculations, okay? I basically did .07 divided by 1.645 on both sides. And then the 0.5 times 0.5, that's where the 0.25 came from. All right, next step, we need to square both sides of the equation. Whoops, sorry about that, guys. Square both sides of the equation. So square root on the right side goes away, the decimal on the left side adjusts. Notice how I'm writing as many decimal places as I can, okay? No rounding. Then I multiply both sides by n, and then divide both sides by the 0.0018, blah, blah, blah. So 0.25 divided by that. And I get that n has to be greater than or equal to 138.062 students. Well, I can't have 0.062 of a student, so I say, all right, if it has to be bigger than that, let's just say 139 students. I need to at least survey that many to stay within that margin of error. All right, here's a practice question. If you'd like to give it a try, go ahead and pause the video, and when you're ready to see the answer, unpause it and see how you're doing so far. All right, so you have to construct the 99% confidence interval. Here's the final answer. I don't have enough room to show everything, but make sure you're doing that state, plan, do, conclude. So state would be something like, I would like to estimate the true proportion of 8 to 18-year-olds in the US who have a TV in their bedroom with 99% confidence, okay? Your plan is checking the NP and the n times 1 minus p, checking if it's random, okay? Your do is this actual number right here. Calculating that, where did that come from, which we've practiced a lot these last few days. And then a conclude would be, we are 99% confident that the interval 0.71 plus or minus 0.026 estimates the true proportion of 8 to 18-year-olds who have a TV in their bedroom. Okay, so I'm not writing it all out, but you'll start to get the idea when you look at your assignment for today. You'll see all that written out in your answer key, and you'll see what I'm talking about, okay? Based on the intervals, there's convincing evidence that a majority of these 8 to 18-year-olds have TV in their bedroom. I would say yes, because that interval is all bigger than 51%. So if you take 0.71 and you add the 0.026, or if you subtract it, no matter what, those percentages are higher than 51%, which is the majority. So I think that's pretty convincing evidence. If the researchers wanted to reduce to the margin of error to at most 1%, well, right now it's 2.6%. So what if they want to reduce it? How many more people do they need to kind of add to their study to make this more accurate? So again, sorry about that, guys. Again, that's where we set up, okay, 0.01 is my margin of error. That's what I'm working with. I was 99% confidence interval, so there's my Z critical value and my standard deviation. They did give us p hat this time, so I'm using 0.71 and then 1 minus p hat, 0.29, and I'm trying to figure out what's n. What do I need, okay? So first thing, divide both sides by 2.575, and then square both sides, multiply by n, and then you're going to do the decimal divided by it, and you should get this number right here, okay? If you're struggling with where that came from, go back to the part of the video where I walk through those steps a little bit more in detail if you're struggling with the solving aspect of finding n. Now, here's the deal, though. You can't have 0.5 of a person, so I round up to 13,653 people. But didn't we already survey, let's see, 2002 randomly selected 8 to 18-year-olds? So I need this to make my margin of error 1%. So actually, if I subtract the 2002 students I already surveyed, really, I need 11,651 additional people in my survey to make this work. Okay, so kind of a trick question there. Don't panic about that too much. Remember, I just want you to practice and stop in for office hours if you have questions, okay? All right, this slide right here is just talking about the graphing calculator. You can do this so much faster by going to Stat, scroll over to where it says Tests, and use 1 prop Z int, and you can type in everything. It gives you your interval. I also have the instructions over here if you have a TI-89. I don't have enough time on this video to show you more, so stop in for office hours if this slide doesn't help you and walk you through those steps sufficiently, okay? But this will save you a lot of time, and you can use your graphing calculator or that desktop app for the rest of this unit, and then you don't have to keep over and over calculating everything, which is kind of nice. All right, so I'm assigning Unit 7 homework number 4, but it's not due tonight, it's due tomorrow night. You can only complete the first 2 pages as of today. So my recommendation, do the first 2 pages today, watch the video tomorrow, and then complete it and turn it in on time. Stop by and see me if you have questions.